Today what we're going to be covering is OOP in JavaScript. And to do so, I've launched a file here. Let me just empty this guy out. So what I'm going to be using is a tool that you guys will be using too in the near future here. It's called NodeMon or NodeDemon, depending on how you pronounce it. Yeah. So basically what it does is it's going to run the file for us on an ongoing basis. So if we make any changes to that file, it's going to be reflected in our console right away. Okay. So down here in my console, let me just clear this out. I'll make this a little bit bigger. I'm going to run this file just using this program, like I said, NodeMon. And we'll just say oop.js, and it's waiting for changes, so we've got nothing in the file right now. But what we're going to talk about is how to create objects in JavaScript. So you guys remember how to create objects in Python? Can anyone tell me what that would sort of look like? Yes. We'd make a class, right, using the class keyword. Okay. And then after that, how would we actually create the object?
Would you make an instance of it?
Yeah, we'd make an instance of it. So how do we do that?
Constructors.
Constructors.
It's just the class name of the variable.
Yeah, so we would essentially invoke the class name like we would a regular function, and that would create an instance of that class. So in JavaScript, the objects that we're going to be creating, at least initially here in this demo, are just going to look a lot like the dictionaries that you guys saw in Python. Okay, so these will just be collections of key value pairs. All right, let's create something now. So let's just say we're going to create this obj, and you'll open it up with a pair of curly braces, and we could just set some properties. So I can say some prop and set that equal to some val. Alright, some other prop, some other val. So notice syntactically we actually do not have to quote these guys here. Unless you have a space in them or some kind of special character situation. Okay, so I've created this object. Now let's just log it out. Oops. Obj. And you can see we've got our object down here, so we've got our key value pairs, right? What if I want to access a specific value from that object? How do you guys think I would do that? So let's say I just wanted to get the sum prop value, or the value for the sum prop key from obj. How would I do that? Dot what? Yeah, exactly. So we can say obj dot sum prop. Okay, and that's giving us back some val. The other way that I can do it is using bracket notation. So I can say sum prop like that, and that would work exactly the same way. So we're still getting the value, right? There are some cases in which you're probably going to have to use bracket notation, and that would be, what if I didn't know what this key name was ahead of time? What if it was in a variable of some sort? So let's just create a variable here. I'll just call it key name, and then I'm going to set that equal to some prop. Okay. What happens if I try to say obj.keyName? Not gonna. Yeah, why not though?
Key name isn't in the obj object.
Correct. So we do not have a key name property inside of our object, right? Okay. So let's just verify to ourselves. This should actually return. It's going to console log out what specifically? Undefined. Yeah, because it's undefined. Okay. So if we go like that, we actually got undefined as expected. So If we use bracket notation, however, we should be able to get that value as we want to. So let's change that. Key name. Okay. So now we're getting the value. Question? Or just like an epiphany?
Yeah,
type
no,
of-
how does that work since you're calling it from the variable name?
Okay.
Instead of the key name?
So yeah, let's kind of go through this line by line, right? Key name has been assigned to this string sum prop, right? So when we put key name inside these square braces, this is actually the value of that is sum prop. So it would be the exact same as if we did obj and then in the brackets we did the string sum prop, right?
So when you do like obj dot key name, it's like obj dot and then the string sum prop, and that doesn't exist.
Yeah, exactly. So what's happening if we do the dot key name, then it's literally going to look for the key name property inside the object, and it's not there.
Okay.
Yeah, so we're getting undefined there. Okay. Any questions about this? You guys feel pretty good about this?
So if you did obj dot sum prop, it'll still show sum down.
Mm-hmm. Yeah, because sum prop is in the object. That key is actually there. Right? Okay. So in terms of when you might use dot notation versus bracket notation, sometimes that comes down to just personal preference because either one will work. So in the case when we actually know the name of the property, we can either use dot notation or bracket notation. If we don't know it and it's being calculated somehow, or it's being retrieved from a variable name, we're going to have to use bracket notation. Okay? All right. Let's have thumbs on that real quick. Make sure that's solid. Good. Excellent. Okay, so what we just did there was we created an object literal, okay, in JavaScript. So JavaScript doesn't really have regular classes in the sense that other languages do. However, we'll see later on, it does have a class syntax that we can use, and I'll show you guys that too later on today. All right, so another way that we can create an object is, and I'll just comment this out here, is we can create a function that will actually return us out an object. Okay? So I'm going to create a human constructor which will return us out a human object. So let's say function human constructor. And then what I'm going to take in are just some basic things. We'll say first name, last name, favorite color, something like that. So I'll just call it first, last, color. Okay? And then what we're going to do inside the body of this function is we're simply going to return out one of these object literals. Okay? So we're going to create it in the body of the function and return it right out. So I will say, I'll do this in 2 steps just to be a little bit more explicit. So let's just say var human equals one of these object literals, and we'll say first name, and then we'll set that equal to the first that we're taking into the function. Last name is going to be set to the last, and then finally favorite color, oops, is going to be color. Okay, now all I'm going to do is I'm simply just going to return out this human that I just created. Okay. So we'll say return human. Okay, cool. But we haven't made any humans yet, so let's create one. So I'm going to create Tom since he is in the front row. So we'll say var Tom equals. the result of invoking this human constructor function. Okay, and so I need to pass in Tom's first. Oops. His last. Okay, I remember. And then, what's your favorite color, Tom?
Yellow.
Yellow. Okay, excellent. So let's just log Tom out. So there it is. Basically the same thing as when we created that object literal, right? The only difference is here I'm creating it from within a function. Now I can simplify this a little bit. Obviously inside this function here, all I did was I created the human object and then I just returned it out. Do I really need to save that variable like that? Or can I just return it? Yeah, I can just return it out, right? And it would do the exact same thing. Okay, so let's do that. Turn this guy. Delete these lines. Okay. Same thing. So again, we're just returning this object literal straight from within the function. Okay. The other way of creating objects that we're going to explore is such a way. It's basically a function constructor way in which we can use the this keyword. Okay. You guys may have come across something similar to this if you're coming from Java, right? Or in Python, how were we referencing the object itself when we were inside of a class? Self. Exactly. So it's essentially the same thing. It's just a reference to the actual object. Okay. So let's do that. I'm going to create a function, actually down here. Let's create a function called human. Okay? We're just going to take the exact same things in it. So we'll take in a first, a last, color. Okay, only this time, instead of returning out an object, all we're going to do is we're just going to set some key value pairs inside that object. Okay? So we're going to say something like this dot first name equals first. This dot last name equals last. Okay, and so forth. So let's say this dot first name equals first. This dot last name equals last. This dot color equals color. Okay. Notice how I don't actually have to return anything from this function. It is implicitly going to return me back the object that I just created using these different key value pairs. Okay. Now, how do I actually create one of these humans? There's a special keyword that we usually like to use when we're creating, one of these instances. You guys know what it is? New. Yeah, we're going to use the new keyword every time we create a new human. Okay, so when we're seeing this inside of a function constructor like this, to create a new instance, we want to use the new keyword. All right, and I think I will create Anthony. Okay, so we'll say new human. Take in his first name, last name, and Anthony, what is your favorite color?
Purple.
Purple. Cool, so let's console log out Anthony. Okay, so let's briefly examine the differences here because something was slightly different, right? You guys see what that is down here in the console? So in the first case with Tom, I'm just seeing essentially one of these object literals, right? Okay, just the curly braces with the key value pairs, that's it. what are we seeing over here?
Human is a key.
What's that?
The human at the beginning.
Human. Yeah, the human at the beginning. Okay. So this is telling us what type of object it is, right? Cool. Now, what if I wanted to add a, let's say we'll go back up to our human constructor here. What if I wanted to add a method to that human constructor if I wanted a person to be able to say their name, for instance? How would I do that? Anyone? Bueller?
Make a method that hasn't
Make a new key.
Yes, I'd make a new key with the name of the method, right? And then I can set that equal to some function. All right, let's try that. So I could say name, and then we'll set that equal to a function. So inside here, how am I going to reference this object?
this.
Yeah, I should be able to use the this keyword, right? Okay. So basically, we're just going to have a little phrase here to say, hi, my name is, and then we'll say this dot first name and this dot last name, right? All right, let's do that real quick. So we'll do console.log. Hi, my name is this dot first name plus, we'll just put an empty space in there, this dot last name. Okay. Now, obviously, I haven't called this function in my code yet, so I need to do that. So let's go with Tom, and instead of just console logging Tom, let's have Tom say name, right? Oops. Okay, so we got what was expected there. He was able to say his first and last name. Cool. So the special thing that we're going to see with this kind of construction is that we have access to a special object called the prototype. Have any of you guys heard of prototypes in JavaScript? Come across this concept?
The singly linked lists.
Single linked list. Ah, yes. Yeah, you guys did touch on those. Exactly. So what the prototype is it's this special object that essentially sits above the objects that we're working with, and we can use it to assign some different properties and methods that we want the objects to have access to. Okay? So it's kind of like a class in that sense. If I create a method that resides on the prototype, each object is going to have access to that. So let's do that. So let's take our human down here, and let's add a sayname function to the prototype. So how do we go about doing that? Alex.
Isn't it like prototype something?
Yeah, I mean you're certainly on the right track. Let's be more explicit though. So I want to add a sayname function or method to the human prototype. How do I do that?
You don't have to use the prototype. You can actually do it inside of the class if you want to.
Yes, I could, but I'm not doing that. So let's add it to the prototype. Good. Dot prototype dot say name. Okay. And then I'll set that equal to some function. All right. Cool. So basically we can just borrow the code that we have up here, right? I'll just grab this. Okay, great. And now we have this human down here. We've got Anthony. Let's have him say his name. So I'll comment that out there, and we'll say Anthony dot say name. Okay. Right. So that's working the way that we're expecting. Now the other way that we can establish methods, as Alex was saying, is that we could put it inside the actual object itself. Okay? So rather than attaching it to the prototype, what would happen if I came inside human here and I said something like this dot say name equals a function. And let's say that we have this say something a little different to tell us that, hey, we're inside the object constructor itself. Okay, so that we know that it's in contrast to when we added it to the prototype. So let's just say console.log inside the inside the object itself. All right. Now, before I save this, I want you guys to think about what do you think is going to happen here. So we've got this function in two different places. We've got it right inside the actual constructor function, and then we also added it to the prototype later on. So I'm going to have a show of hands in a minute. How many people think that this version is going to run, the one that's inside the function constructor, and how many think the other one that we added to the prototype is going to run? All right, show of hands. How many people think this one will run? One contrarian. All right. How many people think this will run, the prototype? Okay, so maybe like 5-6 people think that the prototype's going to run, and then one person thinks, okay. All right, so here's how this works. What JavaScript is going to do is it's first going to look inside the object itself to see if that function actually exists inside the object. Does it in this case? It does. So it will run this because it does exist. Now in the case that we didn't have the function inside this constructor function, what it's going to do then is it would then go check the prototype. Does the function exist on the prototype? If it does, it'll run it. What happens if it doesn't exist on the prototype? Do you guys think, if you had to guess?
Your computer's going to go.
Yeah, basically, right? So what kind of an error might we get at that point?
It's not defined.
So it might say something like undefined is not a function, right? Because you're trying to invoke this function that is simply it doesn't exist in your program. It's undefined. All right. So let's test this, test our hypothesis, and make sure that this is working. So notice that when I saved it, we are inside the object itself. Okay? So again, just to reiterate, JavaScript is going to check inside the object itself to see if that function exists on the object. If it does not, where is it going to look then? It's going to look up the prototype chain. Okay? So if it exists on the prototype, it will run that function. Now, if it doesn't exist on the prototype either, it will then keep going up the prototype chain until we're at the very top. So at the top of the prototype chain is null, which means that there obviously would be no functions on null either, so you're not going to find it there. Okay, let's have thumbs on this, on the prototype chain. All right, got a clarification here. You? Good.
84.7%.
All right, cool. Well, let's have some clarifications. Anna, clarification.
Oh, it's like it makes sense. It just I still feel like I think it just for me it's all about like practicing it out myself.
Okay. Yeah, I mean, you probably won't have like tons of practice with this concept, but I just want to make sure that conceptually we kind of understand. Okay, if this thing exists on the object itself, that's what's gonna run. Right?
So what's the purpose of like having the prototype? Because
That's my question.
realistically, you would just have this function in there on its own. Right? So
Well, do we really want to store the function in every, I don't want to say instance of the class, but in every object? What if we had a whole bunch of different functions? What if we just store those on the prototype itself, and all these objects will still have access to them?
So we just use the
But
prototype to access our. So we put all those in the prototype just to access it, so you can access it from any point, right? Is that the point of a prototype?
well, it gives access to the functions to the objects. Right.
So if I understand correctly, if you put the function in the I guess pseudo class or whatever, if you put it in there,
In this constructor
Right.
function.
Right.
Okay.
If you put it in there, then every object will have that function in them. But if you
Correct.
put it on the prototype, it's not. It's just like a pointer to the prototype.
Yeah, so each one of these objects is going to have a pointer to its prototype. So if we wanted to log out, say, Anthony's prototype, we could do that. So let's do console.log Anthony.prototype. Hang on one second. Proto, I believe, is how we get to it. Okay. So here we actually get the prototype, and you can see that say names on it. Right? Okay. So in this case, that function exists in both places. It exists both in the object itself and then also in the prototype. So the only question is, okay, which one has precedence? Well, the one that's inside the object will have precedence. Okay. Okay, cool. So I wanted to make sure we kind of had that locked down before we touched on the class syntax, because now JavaScript, as of, I believe it was ES 2015 or ES 6, has this class-based syntax where we can create these quote classes using the class keywords. So they look pretty familiar to us, but they're actually operating on top of this prototypal inheritance, okay? Which means that we still have a prototype chain underneath the hood. We're just using a different syntax to express it.
I have a question for you.
Yeah.
The function that's inside the object constructor,
Mhm.
can you change it outside of the object constructor? Or do you have to go back to it if you wanted to make it say something else?
Are you asking, could I then say Anthony.sayName is some other function? Yeah. Yeah, absolutely. Let's try that. So let's go Anthony.sayName equals a function. And instead of what we were doing before, let's just say redefined, if I could spell it right, redefined Anthony function. Okay. So all we did is we changed that specific function that was on Anthony. Now, would that change that function that was on all the other humans that we had created? So let's say we had created some other humans. In fact, let's do that real quick. So we've got Anthony. Let's create one more. How about Jessica? You're in my sites. Jessica. Yoon. Favorite color? Blue. Nice. Okay, so we've got Jessica. We've got Anthony saying his name. Let's also have Jessica say her name. So what's going to happen now? So Anthony's say name has been redefined, right? We changed that. Okay, fair enough. What about Jessica's say name, though?
It's gonna be the same as the other.
Should be the original, right? Because we didn't actually modify it. So sure enough, we have Jessica inside the object itself, just as expected, because we didn't change it on her. We only changed it for you. Okay. All right. And by the same token, if I were to then change that prototype function, would that change any of this here? The output that we were getting?
No.
No, because we're only using the ones that were inside the function constructor, right? We're not even looking up the prototype chain right now. Okay.
So is prototype more efficient?
Yeah, ultimately it is, right? That way we don't have to store these functions on every single instance, every object. Okay. Cool, so let's explore one other syntax here, which, as I said, is the new class-based syntax. So here what we can do is we can create a class, and I'm just going to call this human class. Okay, and then inside there, what I can create is a constructor function that will act in the exact same way as what we were doing up there. So we'll say constructor, which is going to take in a first, a last, and a color. And then inside here, I'm going to do the exact same thing. So I'll just say first name equals first, this dot last name equals last, this dot favorite color equals color. Excellent. And then inside the class, I can also add the say name function, right? So this is how we do it. Notice how we don't need to use the function keyword here. We can just say the name of the function.
Will that be on the prototype?
Should be. Yeah, exactly. So we'll verify that as well. So inside say name, let me just grab the code that we had here. Cool. And then let's console log out human class dot prototype or dot proto. Okay, so notice how the human class is prototyped same name. When I log that out, it's telling me down here that I got this function same name, right? So the human class's prototype has that available on it. Okay, so let's create a new instance of the human class. So I'll say var, who do I want to create? Miguel, I see you back there. New human class. Your last name, Miguel? Martinez. That's right. Color. Black. He's the dark one. All right. Cool.
It goes with everything. It can be classy, kind of scary. Just has so many different.
Yeah, it does go with everything. That's true. Okay. So cool. If we log out Miguel, like I did here, it's saying, obviously it's giving us the class name, which is good. and then we're just getting all these different key value pairs. Do we see say name in there though? No, so it's not actually on Miguel himself, the actual object. Where is it? It's on the prototype. It's available on the prototype. So if I call Miguel.sayName, and I'll do that down here, say name, working is exactly as expected, because it did not find it on Miguel's object, so then it had to travel up the prototype chain to the next level higher and found, Miguel's there. How would we extend, quote, extend from a class using this class-based syntax? Have you guys seen this before?
What do you mean by extend?
So, what if we want to inherit from the human class? In other words, take all the functionality that's built inside the human class and then maybe add some other things to it. So maybe we're going to create, I don't know, a wizard class or something silly like that.
It would be the same way as in just putting the one you're inheriting inside the parentheses.
So that's how we would do it in Python. So here, if I'm using class-based syntax in JavaScript, I could say something like class wizard extends human class. Okay. So what if I wanted to pass all those same things that I'm taking in? So in my constructor, if I'm taking in a first, a last, a color, and maybe I'm going to take in some fourth thing. I don't know, what would a wizard have? A power level or something like that? A wand. Yeah, that's cool. Let's do that. Wand. All right. So how do we actually run the human class's constructor function? Does anyone know? So we have this keyword called super that we can run, and you can see VS Code is telling me here it's going to take in all the things that we were taking in our human class, right? So this is essentially, we're going to be invoking the parent class's constructor function by passing in those things. So I can simply pass those through, so we'll say pass in the first, pass in the last, and pass in the color. And then what I want to do with this wand is I want to do my assignment in here. So I can say something like this.wand equals wand, right? This.wand equals wand. And then I'm just going to create a little function in here. We'll say my wand. It doesn't sound right, but we're gonna. Sounds really weird. All right, so let's just say console.log.
Morley?
Yeah.
So when you type out the function, that gets added to the prototype.
Which one's getting added to the prototype?
The same I want. So the one that you
Yeah.
just
Yeah. So this will be added to the prototype of wizard, right? It's not being. It shouldn't be added to the prototype of human, though, because that has a different prototype, right? Okay. All right, so we've got that, and now let's actually create a wizard. Who wants to be a wizard?
Harry Potter.
Okay, well, Ryan, since you volunteered, you are the wizard. New wizard. Okay, so Ryan Billings, right? Plural?
Yep.
Favorite color?
Black.
There we go. We got a dark crowd. All right, and you want a Harry Potter wizard, is that right?
Yeah, I'm just rewatching all the Harry Potter.
Okay. All right.
the elder one.
Elder wands. There we go. All right, say my wand. Okay. So here we go. My wand is Harry Potter. And then let's also just say name from Ryan as well, so that we can make sure that we properly extended this guy, right? So here we're still able to say, hi, my name is Ryan Billings, because that is available not on the wizard's prototype, but on the human class's prototype. Right? Okay. Any questions about what we did here?
So anytime you declare, you use the class, and you put a function in, it's always going to go to the prototype.
To the prototype, yeah, exactly.
And
So
if you-
so that's why we kind of covered the prototypes first, because that's what's being used under the hood here if you're using class-based syntax.
Okay.
Thumbs. Okay. Just good.
And the time to process.
Need time to process. Okay, good. All right, so I saw Long had some. You got some clarifications on? Anyone else?
One question, you said like human class prototype and wizard prototype, but you never made prototype, so does it make it by itself?
Well, it's available automatically. So yeah, JavaScript has this prototype available when we create a class, or if we just create an object like we were earlier, right? Using the new keyword. Now, what happens if? Let's double check something here. What if I were to console log the prototype of this object right here? What do you think that would be? So we'll say obj dot
Be none.
should be null, right? Yeah, it was undefined. So let me just put something in front of this log. So this is the, yeah, let's do double under proto. You're right. Prototype of an object literal
Can you add prototypes to literals? Object literals?
What's that?
Can you add a prototype to object literals?
Well, you can see the the prototype for it was just an empty object. So what if I try to get the proto of that? What happens there? Null. Okay, so finally we've reached the top of the prototype chain. So at the very top is null. There is no object or no prototype beyond that. But I don't want you guys to worry about that. I was just playing around. It's nothing to spend a whole bunch of time thinking about.
So all objects can have a prototype?
They can have a prototype, yes. And normally, so if we're using the object constructor or the function constructor like we did down here, normally we would want to actually add our methods to the prototype rather than just putting them right inside here. Because this, again, they're being stored on every single object that we're creating using this function. Versus on the prototype, we create that function one time, and it just exists on the prototype. Okay. All right, you guys all ready to get to work? It's a sleepy crowd today.
Start this party.
Start this party. Yeah, let's do it. And then at 3 o'clock, we'll meet back up for some hoisting activity.